So we created this selector in the last lesson. Now this selector has a tiny problem. The problem is that this filter method returns a new array every time we call this selector. Let me show you. So here in index.js, we call this function. Let's store the result in a constant called x. Then we duplicate this line, and this time we store the result in y. In this case, the list of bugs is not changed. So we have 3 bugs. The first bug is resolved. But when we call this function twice, we get 2 different results. Take a look. So let's see if x equals y. Now back in the browser, we get 2 different arrays in memory. Now, why is this a problem? Well, you know that in React, if the state changes, our components get re-rendered. So if we haven't changed the list of bugs, we don't want our components to re-render. That is the problem with this filter method. Now, this problem aside, let's imagine that this logic, the logic for getting the unresolved bugs, is a bit expensive. So every time we call it, we have to wait half a second. Now, what if the list of bugs is not changed? We don't want to wait half a second every time we call this function. So this is where we can use memoization. Memoization is a technique for optimizing expensive functions. So let's say we have a function that takes x and returns y. We can build a cache of input and outputs. So in this cache, we can store inputs, let's say 1, and outputs. So if we call this function and give it 1 as the input, we get 2 as the output. Now, next time we call this function, before we execute that expensive logic, we can look at this cache. We know that we previously called this function and passed 1 as the input. So we can get the output right from the cache. There is no need to recompute it. This is memoization. So by memoizing the selector, we can solve the 2 problems I talked about. For example, if the list of bugs is not changed, we can get the unresolved bugs from the cache. So we're going to have a single array in memory. This array is constructed the first time we call this function, right? Also, by memoizing this function, we can improve performance. So if we have the result ready, there is no need to recalculate it. Now, how are we going to implement memoization? Well, we don't have to implement it by hand. We can use a library called reselect. Let me show you. So open up a terminal window and install reselect. The version I'm using is version 4.0. Now, on the top, we import create selector from reselect. With this function, we can create a memoize selector. Let me show you. So here's an example. We call create selector and give it 1 or more selector functions. So here's the selector. It gets the state and returns state.entities.bugs. Now, the output of this function, which is the list of bugs, gets passed to what we call the result function. So this result function takes the list of bugs. Now here we compute the list of unresolved bugs. So we apply our filter. We want to get the bugs that are not resolved. Now here's the interesting part. With this selector, if the list of bugs is not changed, this logic is not going to be executed again. This selector will return the result from the cache. Okay, so let's export a constant called getUnresolvedBugs. And now we don't need this previous implementation. Now, let's see if we call this function twice, we get the same array or not. So take a look. We get the same array. So we don't have 2 different array objects in memory. This is the benefit of memoization. Now here we can also pass multiple selector functions. So here's another selector, state.entities.projects. Now, the output of these 2 selectors will end up as the inputs of the result function. So here we're going to have 2 parameters, bugs and projects, in the same order we have defined here. Now, if the list of bugs and the list of projects remains unchanged, this logic is not going to be recalculated again.